Now we are going to factor. Well, you might be like, well, we already factored, right? But what we used to factor was quadratic. So I'm going to do an easy one. X squared plus 5x plus 6 factors into x plus 3, x plus 2, right? We all know this. How does synthetic division tell us if one of these binomials is a factor of the other? Well, let's go back, one more step to what does really a factor mean, right? So you remember back in elementary school, you might have done what was called a factor tree, right? Where you would say, well, 2 times 3 is 6, but that also means that 2 divides into 6 3 times, right? 2 went into 6 evenly. So if we're saying that x plus 3 here is a factor, that means it divides in evenly. What does it mean to divide in evenly? Well, the easiest way to divide is by synthetic division. Drop the first number down, multiply, add, and what do we see? Oh, right, the remainder equals 0. That's the important piece, right? When something divides in evenly, the remainder is 0. So here it's going to give us one of the factors, and we have to find the other factor. Now this one's quadratic, so you know that it's x plus 2, right? But we're going to show by synthetic division that it's x plus 2. 3 is the number that's put aside, 1, negative 6. Drop the first number down, multiply, add. Of course, the remainder is 0 because it's a factor. And then this 1 and 2 are going to tell me that it's 1x plus 2. So that's the remaining factor. But usually I would write my answer as both the free factor and the remaining factor to just show that it's quadratic, it has 2 factors. Try another one. The free factor is x plus 4. It's asking us to find the remaining factor. Again, we know it's going to be 2x plus 1, but we can do this by synthetic division. Negative 4, 2, 9, 4. Drop the first number down, multiply, add. Remainder is 0 as expected, so the remaining factor is 2x plus 1. And then there we have it. Now it's easy when it's quadratic, but it's going to get more complicated and the synthetic division more necessary when it's a cubic polynomial. So the next one, x minus 3 is my free factor. I don't really know that answer ahead of time, right? I have to do synthetic division. 1, negative 4, 12, negative 27. Drop the first number down, multiply, add. By the way, if you don't get 0, you have done something wrong because they are saying this is a factor. So those leftover numbers turn into x squared minus x plus 9. Now, if that was factorable, I would factor it again, but it's not, so I'm done. And I guess you could refoil it out to show that it's true, but it seems like that you're going to know you got it right? Here, x plus 4 is my free factor. To find the remaining factors, I'm going to do synthetic division, drop the first number down, multiply, add. Remainder is 0 as expected. This is 1x squared plus 0x minus 1, or x squared minus 1. Now, since that breaks down, I'm going to carry down the given factor, and the remaining 2 factors are x plus 1, x minus 1. What's the difference between a factor and a 0? So let me go back to my good old x squared plus 5x plus 6 equals 0. When I break that down, those are the factors, right? Oops. Those are the factors. How do I find the zeros? Well, the zeros are those solutions, those x-intercepts where the graph crosses the x-axis, and I do that by solving my mini equation, and then I get the zeros. So there's a subtle difference between factors and zeros. So these are the same problems, but instead of giving you a factor for free, we're giving you a 0 for free. And again, this one you know, but x equals negative 3 is given to me for free here. What factor does that come from? X plus 3. What's the remaining factor? Well, I don't really need synthetic division. I would know that that's x plus 2. And so then the remaining 0 is negative 2. And again, I would write both the free 0 and the one I found in the answer to reinforce that a squared or quadratic equation has two answers. Trying again now with a cubic equation. The free 0 is 2. The free factor that comes from is x minus 2. I need to do synthetic division. Notice I'm putting the opposite of the factor aside, which is the same as the 0. So you could think of it that way, of putting the 0 aside. I'm now doing my synthetic division. Of course, the remainder is 0. It's giving me this 132, which tells me x squared plus 3x plus 2. Can that be factored again? Yes, it can. X plus 2, x plus 1. So now I get my other zeros, and you can just solve them like that, negative 2 and negative 1. So I notice it was a third power, and it had 3 answers. One more. Free 0 at x equals 2. Factor that comes from is x minus 2. Synthetic division using the opposite of the factor, which is the same as the 0. Drop the first number down, multiply, add, multiply, add, multiply, add, and then I'm going to get x squared minus 2x plus 2. Does that factor? Does not factor. Uh-oh. If it asked for just the factors, I'd be good, right? So we had this one up here that didn't factor, but I was good here because it was asking me for factors. Now it's asking me for zeros. So how do I find a 0 from a quadratic equation that does not factor? How do I find a 0 from a quadratic equation that doesn't factor? Yes, use the quadratic formula. That's what it's for. That is what the quadratic formula does. It finds zeros of quadratic equations that don't factor. Minus 4ac all over 2a. So this turns out to be square root of negative 4 over 2, or 2 plus or minus 2i over 2, or 1 plus or minus I, which stands for two roots, right? 1 plus I and 1 minus I. Plus I had the free root of 2, so a total of 3 roots. So all of that can be summarized in the fundamental theorem of algebra. This is so big, but it's so simple. The number of roots is equal to the degree of the polynomial. The number of roots is equal to the degree of the polynomial. In other words, if it's a squared, quadratic, it has 2 roots. If it's a cubic, 3, it has 3 roots. And you'll have a couple in the homework that'll have 4 roots. That'll be to the 4th power. Those are a little tricky. We won't go any higher than that. Next year in pre-calc, you might do some more. But yeah, that's the big deal there. And the number of roots is equal to the degree. Factors and zeros.